Hi, I am a student from Weltech Dr. RR and Dr. SR Technical University. I am from IT department and our project is optimal allocation of virtual resource and cloud computing network using mixed integer programming. My name is Mahendran and my project member is B. Ashok and our internal guide is Kritika. Abstract. Moving moving away from a traditional data center oriented model, distributed cloud extends over a loosely coupled federated substance, offering enhanced communication and a computational service to target end user with quality of service requirements. Here we are providing an optimal network cloud problem as mixed integer programming. Existing system distributed cloud extends over a loosely coupled integrated substrate, providing enhanced communication and computational service to target end users with quality of service requirement as declared by the future internet vision. It requires delivery of user-driven set of virtual resources. Disadvantages: it requires delivery of user-driven set of virtual resources, which is dynamically allocated to actual substrate resources within network clouds. Creates and also it creates the need to revisit resource mapping algorithm. Objective: our scope is to consider the dynamic provisioning, configuration, reconfiguration, and optimization of both computing resources as well as network resources in cloud computing. By providing a unified resource allocation framework for network cloud, first we will formulate the optimal network cloud mapping problem as mixed integer programming problem. By indicating the objective related to cost efficiency of the resource mapping procedure, the main efficiency of the proposed approach is that it allows for the flexible, comparative, and structured performance evaluation. Advantage: the advantages: it allows flexibility, structured, and comparative performance evaluation. The capacity of physical resources can be multiplexed among requested resources, allowing us to accommodate more requests. And also, it adopts a heuristic methodology for a resource allocation. System requirements: the hardware requirements are processor Intel Core 2 Duo, speed 2.93 GHz, RAM 2 GB, hard disk 500, keyboard standard Windows keyboard, mouse, monitor LED. Software configuration: Windows 72 7. List of modules: here we are having 4 modules: resource allocation, resource mapping, contribution, and structured network cloud mapping. Module description: resource allocation. In the proposed methodology, the resource mapping solution is also static in sense of the resource allocation does not change for the duration of the lease from the cloud provider. However, to our approach, dynamic reconfiguration of virtual network mapping based on current traffic conditions could be used to improve the efficient utilization of substrate resources. Resource mapping. The resource mapping provides an overview of experimentation environment implemented to the test of efficiency of the proposed solution. In addition, in the application of proposed resources mapping methodology in a prototype implementation utilizing contribution and structures. Contribution and structures. We provide a method for efficient mapping of user request for virtual resources. The problem efficiently amounts to virtual resources to substrate resources with limited access of virtual nodes and virtual links, also known as virtual network embedded problem. Network cloud computing. Resource mapping determines the allocation of physical resources to the network cloud request. Resource allocation does not change for the duration of the lease from the cloud provider, while substrate resources are released upon request expiration. Resource mapping is comprised of node assignment and link assignments. System architecture. Here, NG.
This is the system architecture. Actually, the diagram consists of all types of networks interlinked to it, like star, bus, ring, and etc. This is because this avoids data traffic. If there is only a single type of network connected between all virtual machines, then there will be data traffic. But this doesn't cause data traffic. If there occurs any data traffic in one network, then it automatically goes to the other network and the data transfer is successfully done.
About the system architecture, the system composed of virtual networks of virtual machines capable of live migration across the multi-domain physical infrastructure. By using dynamically availability of the resource, a virtual computation environment is able to automatically relocate itself across the infrastructure and scale to its resources. A cloud broker acts as an intermediary between the buyer of the cloud computing service and the seller. It provides its service to the cloud provider in a network where the virtual machines are allocated. Virtual machines are allocated, which provides virtually resource that improves the current traffic condition in the cloud computing networks. Input design. It is the process of converting a user-oriented description of the input into a computer-based system. It is achieved by creating user-friendly screen of the data entry to handle large volume of data. The goal of designing input is to make the data entry easier and to be free from the errors. The data entry screen is designed in such a way that all the data manipulations can be performed. It also provides record viewing facility. Output design. A quality output is one which meets the requirements of the end user and presents the information clearly in any system. Results of processing are communicated to the user and to the other system through outputs. In output design, it is to determine how the information is to be displayed for immediate need and also the hard copy output. It is the most important and direct source information to the user. Efficient and intelligent output design improves the system's relationship to help user decision making. Here is the screens. Here is the screenshots for the project. Now we are initializing the cloud server. The cloud server consists of the destination IP and some of the cloud client systems. Then we are initializing the client 1, client 2, client 3. Now the virtual router is going to be initialized. Now we are going to send the data to the client system by providing a destination IP address and the size of the packet. Once the packet size and the destination IP is done, click on the response button to send the data to the clients. If we click on the response, the output is showing as resource allocated. These are the cloud system which consist of the data and the buffer size. And the virtual router consists of a source and the destination IP that is transmitted. Thanking you.